Right. Let's see under the subtopic of a double angle formula, and I'll show you how to solving this type of question. All right. So if they ask you to prove that, okay, they ask you to prove that. So I've been doing proving here. So as your left hand side, you will have sine 2x over with 1 plus cos 2x, right? You see, from a double angle, it become a single angle, right? Become 1x. So it means you will need to involving the use of double angle formula. And you know that sine 2x, you have the formula for sine 2x, you have 2 sine x cos x, and cos 2x you have cos square x minus sine square x, 2 cos square x minus 1, and 1 minus 2 sine square x, right? So for sine 2x, you only have one choice. You only have one choice. So which you have to choose 2 sine x cos x, right? You have to choose 2 sine x cos x. But for 1 plus cos 2x, so we observe that there is a 1 here, right? How to eliminate the 1 here? Eliminate 1 here, I must choose a function which have negative 1, right? Negative 1. So I choosing 2 cos squared. Cos 2x I replace with 1 plus 2 cos square x minus 1. So that these two will be eliminated. So you will have 2 sine x cos x over with 2 cos square x. Cos square means cos x, right? You have cos x, you have cos square x. So then the cos x eliminate and the 2 is eliminated. Finally, you have sine over cos. Sine over cos is tangent x, right? So you have already proved that this identity is true, right? So if this identity is true, you already proved that this identity is true. Of course, you can apply this identity to solve some cases in trigonometry. For example, this question already said hence, means you need to apply this identity here. All right. Okay. Let's see how to doing the part A. All right. You can try first. You pause the video. All right. Let's continue by solving question A. All right. Question A. So, okay. So question A is about using the identity, right? Using the given identity to help you solve, show that this is 2 minus square root of 3. So tangent 15. So as you know that tangent 15, right? So you know that tangent, right? As you know that tangent x is the same as sine 2x divided by 1 plus cos 2x, right? Sine 2x over with 1 plus cos 2x. So tangent 15 you can rewrite as sine 2 times with 15 over with 1 plus cos 2 times with 15 degree. So which will give you sine 30 degree over with 1 plus cos 30 degree, right? You have already proven that this identity is true. So you use this identity to evaluate a value for trigonometry. So as you know that sine 30 is 1 over 2, right? And 1 plus cos 30 is square root of 3 over 2 that you already memorized by using all the special value, right? Of all the special angle. So now, and then you multiply 2 up and down, because you want to eliminate the 2, right? So you have 1 over with this one, you multiply 2 inside. So you have 2 plus with square root of 3, right? This is a irrational number, it's a surd, right? So I'm going to express this in the form of a plus b square root of c. So then I multiply with conjugate. Multiply with conjugate. Do you still remember? That is how to, you must make sure the denominator is a rational number. So if you multiply these two, you will have 4, right? 4, 2 minus, then you have minus 3, right? 1 multiply, you have 2 minus square root of 3. So this one you are getting 1, right? 1. So 2 minus square root of 3 divided by 1, you will have 2 minus square root of 3. You have already shown that tangent 15 is 2 minus square root of 3, right? Let's see part B. You can try first before you look at the video. Okay, let's look at this. Tangent 67.5. So based on this identity, tangent 67.5 is equals to sine 2 times 2x, means 67.5 degree divided by 1 plus cos 2 times with 67.5 degree. And you were getting sine 67.5 is 135 degree, right? Or will be 1 plus cos 135 degree, right? So you have to know how to evaluate sine 135. So let's look at what is sine 135. Sine 135 is in the second quadrant, right? It's in the second quadrant, which you have 135 degree here, and here will be the 45, right? 45. The supplementary angle for this will be 45 here. So 45. So it means the acute angle is 40 here, but for this quadrant, add sugar to coffee. So for this quadrant, sine is positive, right? Sine is positive. So it means this one is positive in this quadrant, and sine, so you have to have the acute angle here. The acute angle corresponding for this one is 45. 45. So which give you square root of 2 over 2, right? Sine 45 is square root of 2 over 2 or 1 over square root of 2. So let's look at cos 135, right? Cos 135 is the same. Is the supplementary angle is 45 also, but because cos in this quadrant is negative, cos and tangent is negative, so you have to put a negative here, and cos 45 degree, and cos 45 and sine 45 is actually the same, which is square root of 2 over 2, right? So I'm going to put these two value into the function here. So I have sine 135. Sine 135 is square root of 2 over 2. And for this you have 1 plus cos 135. Cos 135 is negative square root of 2 over 2. Right? Then you evaluate. Very easy. You multiply up and down by 2 because there is a 2 here, right, on the denominator. So you multiply by 2. So the faster way. So you multiply by 2, you cancel out, then you have square root of 2 over with 2 multiply 1, you have 2. 2 multiply negative, you have negative square root of 2. Right? So this one is also, you need to multiply with the conjugate of the third here. So which is 2 plus square root of 2, 2 plus square root of 2. So you expand. You are getting 2 square root of 2, 2 square root of 2, and 2, right? Plus with 2. And for the denominator, you will have 2 times 2, you have 4. And 2 square root of 2 minus 2 square root of 2, 0. And you have minus 2 here. So at last, you're getting this 2 is a common factor. So I'm taking out the 2. And 4 minus 2, you have 2, and you cancel out, then you are getting square root of 2 plus 1 shown, right? So it means that you have already using this identity to evaluate the values of tangent 67.5, which is square root of 2 plus 1. Alright, that's all for this video.